So we are working on solving our radical equations today. So as you can see, there's only 3 simple steps in order to solve them. First one, you want to isolate the radical. So whether we're trying to solve a square root, cube root, fourth root, that doesn't matter. You still want to isolate that radical so it's completely on its own. Next step, you will then raise both sides of the equal sign to the power that is equal to your index. So what I mean by that is if you have a square root you're dealing with, you will raise both sides to the second power because it's an index of 2. If it's a cube root, you raise both sides to the third power. So whatever that index is, whatever root you're looking for, that's the power you're going to end up using. And then we're going to solve and check. So you get the radical on its own, raise it to the power equal to the index, and then solve and check. So let's take a look at our first example. We have the cube root of x minus 2 plus 1 equals 4. So I'm going to go through step 1 and isolate my radical. So I'm going to subtract that 1 over so that that cube root is by itself. So I get the cube root of x minus 2 equals 3. So now this is a cube root, so that means my index is a 3. So I'm going to raise both sides to the third power. So again, whatever that index is, that's the power you use. So x minus 2 equals 27. Because 3 to the third is 27. Add my 2 over. And I get x equals 29. With radical equations, you definitely need to check because a lot of times answers end up getting rejected. So I'm just going to plug in my 29 quick. See if it does, in fact, work out. So underneath my cube root there, I get the cube root of 27. Cube root of 27 is 3. So 3 plus 1 is 4. So that does check out. Our answer is good. So get the radical by itself, raise it to the power, solve, and check. We're going to hang on to number 2 for a second. Let's go down to number 3 and 4 first, and then we'll circle back to number 2 after that. So number 3 here, my radical is not on its own. So I'm going to subtract my a. So 3 minus a equals the square root of a minus 1. What power am I going to raise it to? Second. So I'm taking a square root this time. So my index is a 2. I'm going to raise both sides to the second power. People always still messes up over here on the left side. 3 minus a squared is not 9 minus a squared or 9 plus a squared. Remember, that ends up creating a trinomial. That's 3 minus a times 3 minus a. So that gives me 9 minus 6a plus a squared equals my a minus 1. Because when I do my distributive, 3 times negative a is negative 3a plus a negative 3a, which is where my negative 6a comes from. It's from those, multiplying those outsides and the insides. So, subtract my a over, add my 1 over, and then what are we going to do next? Begins with F, rhymes with actor. Factor. What will this factor into? Multiplies to 10, adds to give us negative 7. 5 and 2, both negative. So I got a equals 5, and then a equals 2. But we do have to check to make sure that they both work, because they may not both work. So I go back up to the beginning. I plug in a 5, 5 minus 1 under that radical is a 4. Square root of 4 is a 2. I can already see that one's not going to work out because I get 3 equals 7, which is not true. And then my 2 plus the square root of 2 minus 1. 2 minus 1 gives me 1. Square root of 1 is 1. This one checks out because 3 does, in fact, equal 3. So taking a look at number 4 there. Is my radical isolated? Yes, it is. What power am I going to raise both sides to? A second. So even though I have that 2 in the front, you could get rid of the 2 and divide it over, but then I would end up with x over 2, and that wouldn't be easy when I was squaring. So that's why I left it for now. But when I do go to square that, I am going to square that 2 out in front first. That does get squared, so that would become a 4. And then it's times the stuff underneath the radical. Over here, this would become x squared minus 4x plus 4. So distributing my 4. Then I'll subtract 4x and 4 over to the other side. And my 4's actually end up canceling each other out. So what kind of factoring is this going to be? Not dots. It's not perfect squares.
Oh,
GCF, yes. So x times x minus 8. So I get a 0. I get an 8. Do we get to keep both 0 and 8? Probably not. But let's just check to see which one we're going to end up getting rid of. So if I plug in my 0, I end up with the square root of 1, which is 1. 0 minus 2 gives me a negative 2, so no, that's not the same. Plug in my 8. We would get radical 9, which gives us a 3. So we end up with 6 equals 6. So that one does, in fact, work. Questions on that so far? All right, let's go back up to 2. What's different about problem number 2 there? It's got 2 radicals. That makes things a little bit trickier. When you have 2 radicals, it does make things a little bit trickier. So what we want to do is you still want to isolate the radicals. So you want one radical on one side of your equal sign. You want your other radical on the other side of the equal sign. So I'm going to add my 2 times the radical of x plus 8 over. So now my radicals, they are isolated. I have one on one side, I have one on the other side. So what are we going to raise each side to what power? The second. So 9 times the x minus 2 equals 4 times the x plus 8. Distributing. Nine x minus 18 equals 4x plus 32. Subtract my 4x. Add my 18. And what do we get? X equals 10. So let's just check, make sure 10 works. So I'm going to plug in my 10. So 3 radical 8 minus 2 radical 18. Right now it's not working, so we have to simplify in order to subtract them, which is what we went over last time. So our perfect square that comes out of 8 is 4. 4 would become a 2. But times that 3 we already have makes it a 6. The perfect square that comes out of 18, 9. So we end up with another 6 radical 2. So it checks out. So we're good with that one. All right, so our next one, what do we want to do first to isolate the radical? Subtract that 4. Now for this one, can I actually divide negative 12 by 3? Yeah. So I'm going to do that because it's just going to make things a little bit simpler and a little bit smaller. Again, that other one I couldn't, because if I did, I would end up with a fraction. This one didn't give me a fraction, so it's okay. So I'm going to square both sides. So again, all I do is get rid of my radical over there on the left side. Right side becomes a positive 16. Subtract my 6. Divide by negative 1. And the x equals negative 10. So let's check it. 6 minus negative 10 plus 4 equals negative 8. So 4, 12. No, this isn't going to work. Negative 8. Not true. So it didn't actually work out. So what do we write? No solution. There's no solution for this one. So we're going to take a look at quickly, graphically, what ends up happening and why we have no solution. So if you don't have your calculators out, grab them now. All right. So what we're going to do is everything on the left side of the equal sign, type that into your y1. So 3 square root of x, or 6 minus x plus 4. Make sure you do actually leave that square root sign, so arrow to the right to get out of it before you put your plus 4 in there. And then negative 8, the stuff on the right side of your equal sign, that's going to go into your y2. So if you're trying to check these, left side is your y1, right side is your y2. If we look at our graph, there ends up being no solution to it because they don't even cross. So mathematically, yes, we could find a problem. We could find an answer, mathematically speaking. However, it does not fit the constraints of both problems, so it's not actually a viable solution. And that's what my graph looked like. Yes. Absolutely. All set? Okay. All right, so why is the answer that you got not the solution. It doesn't fit the constraints of both. We'll call it equations. Nope, we'll call it both sides. Both sides of that equal sign. So it doesn't fit the constraints of both sides of the equal sign. So algebraically speaking, yes, we can find an answer, but it doesn't actually work when we go to check our work. So again, I typed up for you the steps of what to do if you are checking it in your calculator, so you can always refer back to that while you're working. Oh, absolutely. So let's keep trying just a few more problems. So I'm going to give you a minute. I want you to try to solve on your own this next one, the square root of x plus 2 equals x. All right, so square root of x plus 2 plus 2 equals x. So can we keep both of our answers based on our graph? No. Which one ends up getting rejected? X equals 1, because our graph looks kind of like that. So you get to keep that one, which is definitely going to be over there at the 4. X equals 1 would get rejected because, again, it doesn't actually work for both equations. So you can check yourself using that graphing calculator. That's another way you can always do your checks. All right. Again, I'm going to give you a minute. Go ahead and try solving the next one. Okay, so 2x, and then 8 plus 2 radical. Uh-oh, that one goes off our graph a little bit. So we can't really tell too well where they cross. So let's take a look at our table. Our answers we got were 6 and 4. So at 4, they're both an 8. So yes, it checks out. At 6, they're both a 12. So yes, that one also checks out. So for this one, we get to keep both those answers. Both answers are viable. No extraneous here. Mm-hmm.
So when we're typing it in the y equals, you type in the x and not your answer?
Yes.
Okay.
Because we got more than one answer. So I don't want to have to keep going back and retyping the answer that I got.
So technically you can find the answer by using the graph.
Mm-hmm. Yeah. But when the problems say algebraically, I mean, it doesn't work, but that's why we use it to help us check. All right, so now we're going to do just a few more that are a little bit more complicated than the other ones that we've been doing. All right, so this first one here, we already have our radicals as isolated as we can possibly get. Yes, the one on the right side has that minus 2 with it. But if I add the 2 to the other side, then that's just attached with the other radical. So there's really nothing I can do other than just keep moving that 2 back and forth from either side. So we're going to go ahead and we are just going to start squaring and start getting rid of as many radicals as we possibly can. So squaring that radical x, that's pretty easy. That's just going to be x. These ones, I like to write it out a second time because you are going to have to do your double distributive here. We're still going to have a radical when we're done with this that we're going to have to get rid of again in a second. So radical x plus 16 times itself would just be x plus 16. Those radicals would cancel each other out. But then I multiply that by -2. And I get -2 radical x plus 16. And then distribute this -2. And -2 times -2 gives me +4. So we've eliminated one of the radicals at least. We still have one of them, but that's okay. Combining my like terms over here on the right side. And I get x plus 20 minus 4 radical x plus 16. I had the -2 and the -2 makes it -4. So now we're going to follow the same steps we would do if we hadn't done anything yet. We're going to isolate our radical. So I'm going to subtract this x over and my 20. And my x's actually would end up canceling. So if I subtract the x over, cancels on both sides, subtract my 20. Divide by my -4. And so now we're going to square both sides again. So sometimes we end up having to do it twice. So 25 equals x plus 16. Subtract our 16. And we get 9 equals x. So you could use your graphing calculator, look at the graph, see if it works, or you can just plug the value in yourself. I find sometimes with these ones I can do it faster if I just plug the number in like we were doing on the first part. So that gives me 3. 9 plus 16 is 25. Square root of 25 is 5. So 3 equals 3. So same thing with number 9. Our radicals are as isolated as I can possibly get them. That +2, I just keep switching it back and forth to the other side, but it's not really going to do much of anything. So I'm going to square both sides. So 2x plus 11 equals x plus 2 plus 2 radical x plus 2 plus 2 radical x 2 plus 4. Yeah, I'm just distributing. Okay. So we got x plus 6, because you got the 2 and the 4, plus 4 radical x plus 2. So we'll isolate our radical again. So I'm going to subtract my x, subtract my 6. So x plus 5 equals 4 radical x plus 2. To divide by 4 here, that's not really going to help me much. It'll give me fractions again, so I'm not going to divide by 4 here. I'm just going to go ahead and start squaring. So x squared plus 10x plus 25 equals 16. So remember, you got to square the 4, so 4 squared 16 times x plus 2. Plus 32. Distribute that 16. Now we'll get our 16x and our 32 over to the other side of the equal sign. That's x squared minus 6x minus 7. So it multiplies to 7, adds to negative 6. 7 and 1. We don't really have many options there. So x minus 7, x plus 1. So x equals 7 and x equals negative 1. Do they both work? Let's find out. So I plug in 7, I get 14 plus 11 is 25. And then a 9. Yep, so 7 works. Check. If I plug in negative 1, that'd be negative 2 plus 11, so that's 9. Plus 1. Yes, these both actually end up working. We can keep both of them. Again, sometimes they both work. Most times they don't. All right, one more. Number 10, you want to get one of those radicals over to the other side of the equal sign. So I'm going to subtract my radical x plus 5. And then I'm going to give you a few minutes. I want you to try solving that one on your own. So start with squaring both sides. So I square, subtract my 5, and I get x equals 4. Which, let's see here. 4 minus 3 is 1. Bless you. And yes, that's going to check out. That's going to be our final answer there.